Hi guys, today we're going to be introducing the volume of a sphere. So we haven't talked about spheres yet in this unit. We've really just talked about prisms, cylinders, cones, and pyramids. So we've talked about shapes that have two bases, and we've talked about shapes that have one base, but a sphere has no bases. So let's just do a quick recap in case you are still busting through all of this. Anything with two bases, like a cylinder or a prism, the formula is capital BH. So the area of the base times the height. Anything with one base is 1/3 capital BH, or 1/3 area of the base times the height. Okay, so I will go ahead and post those here as a quick reminder. So what we're going to be finding the volume of today is not a cylinder, and it's not a cone. It in fact is nothing like any of those because it has no bases. Okay, so what we're going to be finding the volume of is a sphere. You guys should know that a sphere does not have a base because there's no way to easily set it without it rolling. You actually really have to make an effort to get it to stay still, and that's because there is no base. So the formula that I'm going to give you is right out of your textbook, and it has no capital B. There is no area of the base in this formula. In fact, there's only one number that gets plugged in to this formula, no matter what kind of sphere you have. There's one number. It's pretty predictable. That one number is going to be the radius. So you guys know that every circle has a radius, right? We learned that before we went home. So every circle has a radius, and the radius is the center out. So what I have to best show that to you is this candle. If you look at a candle and you look at it straight on, the wick is in the center. So the radius of this candle would be from the center out, which is about 1.5 inches. Okay, and the diameter is the whole way across, which would then be 3 inches. Okay, so you can do that with a circle, but you can do that with a sphere too. So a sphere, the radius is a little bit harder to measure because it's not so straightforward. Like you're gonna have to set the sphere down, and you'd have to find the top center, and then you kind of have to hover above it and look over it. And it's just not always gonna be super exact, okay? The real way to find a center of a circle or a sphere is by actually like poking into it and finding the center, which you're really not going to be doing when you're working with spheres. So I think the easiest way is to find the diameter, find the whole way across, and divide by 2 if you can't find that like center point. But in our situation, the problems that we're going to be doing, it's just going to be given to you. You're not going to be picking up a tape measure and a sphere and measuring it, okay? It's just going to be given to you. So without further ado, let me go ahead and give you the formula, and then we're going to go ahead and measure this and get the radius and find the volume using the formula so that you can see an example, okay? So here's the formula. All right, so now that you've seen the formula, you should see that the volume of a sphere is 4/3 times pi times the radius cubed, or the radius times itself 3 times. So all we need to know is the radius, because pi is just a button you press, it's just a number, and 4/3 is just a number, okay? So here we go. I'm going to go ahead and try to measure this on camera as best as I can. And I don't want to hold the tape measure upside down like I did the last time. So I'm just going to pretend that this dot is the center. Okay. And if you measure out from the center, this is really difficult, but you would see the radius of this sphere is 2 inches. Okay. Which means the diameter from edge to edge is about 4. I think we can confidently say that the radius from middle out is 2 inches, okay? So that's the only thing I need. That's it. So what I'm going to do is I'm going to go ahead and, actually, I'm just going to write this down and show you a picture of it instead of doing that live. So I'm going to go ahead and show you the formula with 2 plugged in right here. But I'm sure you're also wondering, how do you plug that into your calculator correctly? So let me go ahead and switch views of my iPad, and I'm just going to type it into my computer calculator and then go from there. All right, so I'm actually going to show it to you on Desmos because I feel like that's probably what all of you are using the most. So here is how you could use Desmos to type this in efficiently. You would go ahead and type in your parentheses, and then your 4/3, which is just 4 divided by 3. And then pop out and hit your other parenthesis. So there's your 4/3 times pi. So that's just a simple pi button. And it's keeping the running tally down there so far. So you're always going to see that number first. Every single sphere will be 4/3 pi. Okay, but then you have to end it with your radius. Okay, so it is 2, and you could go ahead and do 2 times 2 times 2 if you want to, but have you ever noticed this little A to B button? You can press that, and then it lets you put in whatever exponent you want. So that's where we would put the cubed. And then you're going to see what that equals. It's 33.510321638, which we, of course, could round that however we're supposed to round it. So that's one way you could type it in. Or you can do like 4/3 times pi times 2 times 2 times 2. And you would get the same exact thing. Some of you probably are going to have a hard time with this second parenthesis. So let me show you one more time. It's parenthesis 4 divided by 3. Oops, I already messed up. 4 divided by 3. And then if you hit a parenthesis right there, look what happens. Problem, okay? So make sure you pop out and then you hit your second parenthesis to get that, okay? And then you would keep going. So I would always recommend you to look in your textbook if you want to see some more examples, but I feel like that one example should be plenty to get you through. I will post one more picture of it completely done at the end for you to screenshot and keep in your notes. But happy volume finding, guys. I will see you with another video tomorrow. Stay tuned.